In this new edition, we are going to discuss about the defects in images produced by the eye students. As you know that mainly there are three types of defects, and one is said as the myopia, the second is hypermetropia, and third is the presbyopia. Okay students, to understand these defects and the correction of this, we have to know what is the myopia, what is the hypermetropia, and as well as the presbyopia. Okay students, myopia, simply we can call it as the short-sightedness. Simply we can call it as the short-sightedness. And what is the short-sightedness? Okay students, first we have to understand what is the short-sightedness. You can see the nearby objects clearly, but you are unable to watch the objects which are far away from you. That is known as the short-sightedness, students. In the same way, the second is the hypermetropia, the reversal of this. In short-sightedness, we said a person can see the nearby objects clearly, but the objects which are far away from him cannot. The same thing, the reversal thing happens here. He can able to see the far objects, that means what? Which are far away from him clearly, but cannot see the objects which are near to him. To understand these two things clearly, students, we must know about the nature of the eye, students. And you know that eye looks like a ball. Okay, this part is known as the retina, and it is the optical nerve. You have to remember one thing, students. Brain reads any message which is in the form of electrical pulses, students. Here, this retina has the receptors on. This retina is made of what? Rods and cones. Okay, you know that all the images are electromagnetic waves. Okay, students. These electromagnetic pulses are taken on retina by means of what? Rods and cones. Rods was that measure the intensity of the light, image, and cone recognize the color, students. Cone recognize the colors and rods recognize the brightness of the image, students. And these electric pulses sent to the brain by means of the optical nerve. There, the brain read that message and we are able to see the objects or images very clearly, students. It's a thing which happened behind. But actually, we said it is the eyeball and it has a thickness which is around 2.5 centimeter. That means I am talking about the diameter. And this front part is known as the cornea. It is a transparent layer. And if you watch this one, it is a convex lens, students. Okay, it is made of gelatin substance supported by the muscles known as the ciliary, students. Most of the reasons which are behind the far-sightedness and as well as the short-sightedness is totally dependent upon the working of the ciliary muscles. If the ciliary muscles are functioning normally, okay students, it means you are not suffering from any kind of eye defect, students. Okay students, then after we have to know two terms which are very important to understand this. One is known as the near point and second is the far point. What is the near point? Near point is nothing but the least distance of distinct vision, students. You have learned that least distance of distinct vision is the minimum distance from the eye up to which the object can be seen clearly. Okay students, it is the minimum distance from the eye up to which the object can be seen clearly. You can understand this thing very easily. Keep your palm in front of your eyes and try to see the lines on your palm. For the most of the people, if the palm is at a distance of 25 centimeter, they can see the lines clearly. Generally, what goes on, if you are the aged person like me, if anyone, they can't see the near objects at 25 centimeter. Okay, students, the near point will change from 25 centimeter to around 100 centimeter or 150 centimeter. In the same way, kids of age around 6 to 10 have the ability to see up to 6 to 10 centimeter only, students. That means what? The near points and far points will change with respect to the age, students. In the same way, for a normal eye, the far point is infinity. Okay, students, these two things you have to remember. What is the near point and as well as the far point? And third and very important is the accommodation of the eye. It plays the major role, students. How it a rule it is? Major role. It plays the major role, students. What is the role of the ciliary muscles? Simply, students, ciliary muscles behaves like the springs. If it is needed, they have the ability to get contract, and as well as they can expand. This expansion and contract leads to the change in curvature of the eyelid, students. The curvature will change. With respect to the curvature, the power of the lens also changes, students. Imagine that these lenses get compressed. These lenses get, this ciliary muscles get compressed. Then what did happen? The curvature will decreases and the lens become thick, students. If it becomes thick, the power will change, students. As you know that power is the reciprocal of the focal length, students. That means what? The focal length will change. If power increases, the focal length get decreases. Okay, students. Sometimes what could happen? These ciliary muscles expands and the thickness of the lens decreases. The same thing is happening here, students. In this case, the power of the lens will decrease. If the power decreases, then the focal length will increase. Then how the focal length is related to this eye we have to understand. Okay, students. See this. It is the lens we have, and say it is the principal axis. It is the imaginary line, isn't it, students? Okay, students, an object is kept at infinity. Rays are proceeding from the object like this, and then learn that the rays are coming from infinity appears to parallel to each other. If this eye is free of all the defects, then what could happen? After refraction, these rays meet at retina and we will find the image. It's a simple story, students. And this distance we call it as the far point. It is the far point. That means what? Object is kept at infinity. Okay, students. And what could happen when the object is at least distance of distinction? Okay, I'm calling it as the near point. If we keep the object at near point, the same thing could happen. The rays are proceeding. After refraction, the same thing will repeat. The rays will meet on the retina if the eye is free of defects. In both cases, we will get the image on the retina only. That means there is no problem with the eye. Okay, it is a healthy human eye, students. Right now, think, students, what could happen? These things being changed. See, I'm taking the same eye here. Okay, students, it is eye. And we have a lens here. Okay, students, and it is the principal axis. Rays are coming from infinity. Rays are coming from infinity, students. They appears to be parallel to the principal axis. Now say there is a probability of forming the image by this lens is of two types, students. One is the nearsightedness and second is the farsightedness, students. See, The rays are proceeding. Here, rays met just before the retina. Here. Means what? The power of the lens is increased, students. You know that power is inversely proportional to focal length. If the power is increased, the focal length gets decreased, students. So, instead of the image to be on the retina, it formed at a particular distance in front of the eye. Means what? Focal length being changed. Actually, it might be equal to the focal length. Actually. But it get altered. That means what? We have to bring back this one, focal length, to the retina again, to this actual value. Okay, it is the focal length of the myopic eye. Okay, students. Then we have to go for a remedy. What is said? Power being increased. Means what? Focal length decreased. Means we have to reduce the power. Okay, students. Then we are taking a lens, students. We are taking a concave. As you know that a concave lens has the negative power. And we are keeping this lens in front of the eye. You see. And you know that concave lens has the ability to diverge the light rays. The rays which are coming here get diverged in this way, students. They get diverged. And you know that we can locate the focal point of the concave lens, students, here. It is the focal point. Then this focal point of this eye lens, okay, turning into the new far point, students. It is the new far point. Actually, it is the far point, students. Okay, rays are proceeding, they have to meet on. Then far point being changed, it came to here. Then the new far point is created by this lens. Okay, and this new far point works like the object, for the eye lens. Listen my words carefully, students. What did happen? Rays are proceeding. They fall on the lens. They get diverged. Okay, students. That means what? They have to bend further. They have to bend further to meet at retina, these rays. Okay, this work is done by this lens. Here I said, what is it for elderly people? Okay, students. The far point is few meters or few centimeters maybe. Okay, students, few meters. Actually, it should be infinity, but it turns into the few meters. Here, say it is up to here. Then what we have to do? We have to keep a concave lens. Here, what happens? The rays coming from the infinity, okay, get refracted. And what's that? They get diverged. If you produce them backward, they appears to be meeting at a particular point, that is the new far point, students. There the image of this rays which are coming from the infinity is formed. Here, a new far point, the image will form of the object which is kept at infinity. Then this image is taken as the object by the eye lens, students. Then what happens? Here the bent, and further it get bent, and again the image is formed on retina. Okay, students, the image will form on retina. Mathematically, we can prove it like this, students. You know that the relation between the focal length, image distance, and as well as the object distance in case of a convex lens or any lens is 1 by f is equal to 1 by v minus 1 by u. Okay, students, it is the new far point. Okay, I'm calling it as the x. Okay, students, and it is the object distance actually. Here. Okay, students, That is, focal length is equal to 1 by v minus 1 by u. Where is the object is kept at infinity? That is, u is infinity and v is nothing but x. If you keep the sign convention to this, it becomes negative x. Just keep the values in, students. 1 by f is equal to minus 1 by infinity. Obviously, it is equal to 0. Then we can get f is equal to minus x or x is equal to minus f. The new far point should be the focal length of the lens which correct the myopic effect, students. It is about myopia. What is the myopia, students? It is the short-sightedness. Myopia is short-sightedness, students. We learn that the power of the lens will increase. Power of the lens will increase. The main aim is we have to decrease the power of the lens by using a concave lens, students. With that, we can correct the myopia, students. Then after, we have to know about, is it the only reason for the myopia? There is no. Sometimes what could happen? The size of the eyeball will increase, students. See, I'm taking the same. Okay. If it is the eye, okay, students, we have the lens here. And what happens? Ray have to fall on the retina as shown here in this diagram. Rays coming from infinity, they have to meet on the retina. Actually, it is the story, students. Actual story. Then what did happen? Here the same rays are proceeding. They come and they form the image in front of the retina, and this image will be distributed along the retina. That means what? It's not forming at a particular point. Then eye get confused over. Then it cannot recognize the image. That's why it appears to be blurred when you are suffering from the myopia. And the second reason is, sometimes what could happen, the size of the eyeball will increase, students. Size of the eyeball will increase. Just imagine that. It is the size of the eyeball and it is increased up to here. Means the focal length being changed. See? If it is increases and the retina is here, that means what? Image is forming in front of the retina. The same thing I showed here, students. Here, the image is what? Actually, it has to fall here. The lens is working perfectly. This image, it is, what's that? With the wrong function of the ciliary muscles, these things are happening. When it expands, maybe the lens is working perfectly and is forming the image here. But due to the increasement in the size, the distance between the image and retina will increases. It also the cause of myopia, students. We have the two causes, students. One is, was that not functioning properly by the ciliary muscles, and second is, was that increasement of the size of the eyeball. Okay, students. Then after, we will learn about hypermetropia, students. And also we learn what is the correction of hypermetropia. I told you already, myopia is said as the short-sightedness, where hypermetropia is known as long-sightedness, students. Or simply we can call it as a far-sightedness. Here, hypermetropia is the biological term, okay, and long-sightedness is general term, which is in usage, students. The same goes with the myopia also. Myopia is a biological term. Okay, students, what is the cause of myopia? We have to understand. The rays are proceeding from the infinity. They met on the retina. Up to here, it's okay. Okay, students. You have learned that we have the 2 points. One is the near point and far point. These persons are unable to see the objects which are near to the eye. Okay. Here in short-sightedness, what could happen? The people are able to see the near objects clearly, but unable to watch the objects which are far away. It is the reversal of this. Here they can see the objects which are at infinity clearly, okay, because the image is forming on the retina, but the objects which are kept at least distance of distant vision. Okay, students, they are unable to see. What happens here? In this case, we said it is the near point. Okay, students. Then I'm removing this part. Already you understood what is this. Here we are learning the function of the eye. Here in this case, what could happen? The lens becomes thin. That means what? Ciliary muscles expanded up. Okay, students. Then the thickness of the lens being decreased. So the object which is at near point forms the image beyond the retina, students. Here the image will form. It is beyond the retina. And what is our work is? We have to bring back the same image. What's that? This image, which form beyond the retina to retina, students. Then we have to make an adjustment. What adjustment? What did happen? Here, the power of the lens being decreased because it becomes thin. We have to increase the power, students. To increase the power, what we are doing? We are taking a convex lens, students. If we add the two convex lens, then the power will increases. Then what happens, students? See, it is a near point. Okay, the actual point, near point, could be the other students. Maybe it is up to here. It is a new near point, students. New near point. It is the actual near point. You know that it is equal to least distance of distinct vision. And this one would be the different. It is more than the actual near point, students. Okay, students. So here the new near point, and we have to use a lens which makes a combined focal length which is equal to this distance, students. The remedy is what? We are using a biconvex lens. It's a biconvex lens. Okay, students? And it will be taken as the object by this lens system. And it forms the image at here. At the previous, that means actual near point. Then the same thing will happen. The power will increases and the bending capacity of the lenses will increase. Okay, the bend the rays more. Then the image will form on retina again. Okay, students. It is about the hypermetropia. Unable to see the near objects clearly because the new near point will be different than the actual near point, students. And what is the remedy of this? We learn that we have to use one more lens, that to a convex lens, because it has the positive focal length. Imagine that it has the power of 2 diopter, imagine, and it is of 4. Then the summation of the two would be more than the power of this lens, that it becomes 6. Okay, students, maybe you understood that what we are doing. Here, it is the actual distance of the object, it is equal to d, and the image formed by the lens is equal to y, it is equal to the new near point. Mathematically, we can write it as 1 by f is equal to 1 by v. minus 1 by u. You know this, students. Here v it is. That is v is equal to y. By keeping the sign convention, it becomes negative. Similarly, u is equal to d and it's also negative. Okay, focal length we have to find. That's why we should not keep any or sign convention to that, because we took a convex lens only. If we keep this, 1 by f is equal to minus 1 by v plus 1 by d. Okay, students. Okay, here v is nothing but y, students. Okay, students. Then it can be written as 1 by f is equal to 1 by d minus 1 by y, or you can write it as y minus d by yd. Okay, students. Our focal length is equal to yd by y minus d. Okay, students. It is the focal length of the lens what we have to use to correct the hypermetropia, students. And the third one is the presbyopia. When the age of the person is more than 30, he will suffer from both eye defect, students. That is the myopia and as well as the metropia. Generally, elderly age people, okay, suffers from this what's that, presbyopia. The presbyopic people use the bifocal lens to correct the defect, students. That means what? They use the convex and as well as the concave. If you see anyone is wearing the lenses which has a D at the bottom, means what? He is using a bifocal lens. That means that it has the two focus, students. I hope you understood this topic well, students. If you like the video, please forward to your friends and don't forget for the subscription, students. Thank you very much.